Good morning everyone. My name is Christine Irish M. Cabrado, and for today we are going to talk about the Thing 5. So this Coursera week covered the 10 things that that the engineers need to know for materials engineering. We are going to discuss about the fifth thing that you need to know. Let us start with first, let us discuss what our agenda is. So, our agendas are, for today's agenda, first agenda is for us to be able to explain and discuss the creep deformation itself. And then in the second one is for us to be able to explain what the creep curve is. And then after that, we are going to explain the creep test. Let us first define what creep deformation is. So creep deformation, so as we look into the at the various categories of the material, so it is defined as the materials used at a high temperature under a high pressure for a long period of time. So it reminded of those various menu of materials introduced on our first segment or the previous weeks. And of course, the materials used before was the ceramics and plastics and polymers. Now, we'll primarily talk about metals and ceramics, but we'll just summarize it in this course. Okay, so let us now continue with this one. So it says that creep deformation generally occurs when a material is stressed at a temperature near its smelting point. So as you can see, uh, creep deformation occurs when a certain material or a certain thing is heated up or cooled down or being set into a temperature where it is not actually used to. Okay, so as we can see that plastics and low melting temperature materials, it includes many solders and it begin creep at a room temperature. So the glacier, we can now say that the glacier flow is an example of creep processes in ice. So it just differs upon putting it in heat or cooling it down. It depends upon that one. Let us look at this creep curve. As you can see, this is the creep curve based upon the tests that we did in the previous week. So as you can see, the first on the first graph, it is the measure of the elastic and plastic deformation in the material over a period of time. So the strain, it was the strain and the stencil test before, and after that you can see that on the second part, it somehow differs upon its performance, since again this is a strain and versus stress test. But on the third part, you can see that the time or the graph, like it has nothing happened. So it is the guy who actually explained this part says that the test was actually boring, or the test results was actually boring, since the elastic strain induced in an alloy at room temperature is independent of time. So as you can see that there is actually nothing happened. It just changed its form, but on the curve itself, it didn't change over time. So we'll discuss the next part, which is the creep test. As you can see, this test is somehow same as the stencil test, but there is something different among the two of them. So this is the equivalent of the standard stencil test. But as you can see, look at the below part at the constant load. You can see that there is a cross head down from the elastic to plastic deformation, and then onto failure. And then on the side part, you can see that there is a furnace. Furnace is used to take it up into an elevated temperature. And then as time goes by, you can see that on the blue part of this figure, you will just monitor its time difference and put the gauge. This is actually the gauge length, and then after that you will monitor it over a period of time, and you will just check if if its length is going to be different over a period of time. That's just going to happen. And then of course, if you use, let's go back here, if you use this creep test over the standard stencil test that we used before, you'll actually get this curve. And then it says here that the strain is no longer boring compared to the strain defined and illustrated earlier. So as you can see, the strain is no longer boring. There is a primary, secondary, and final stage here. And then on the elastic part of the instantaneous deformation, it actually increases, unlike before that it is dependent over time. So yes, as you can see, that this is just the part of our Think 5. This is actually not explained in detail, but we are able to define what creep deformation is and the creep curve. What will happen if you use the creep test instead of the standard stencil test that we used before. And then we are able to explain how creep test actually occur. So as you can see, again, let us summarize everything. That the creep deformation, this is the process wherein materials are used at a high temperature under a high pressure for a long period of time. It's just the material getting in putting in a different temperature where it was not used to. Okay, so yeah, again, this is the fifth thing that you need to know about material science. So again, thank you so much for today, and this is Christine Irish M. Cobrado. So there are a lot of things. There are 5 remaining things that you still need to know. And thank you for watching this video. I hope you learned something, and have a good day. Bye.